Hi, I'm Paweł Spychalski, and although interviews are not really a thing on this channel, it doesn't mean that, well, we cannot do them from time to time. This is why today let's watch an almost a 40-minute long interview I did last week with Kevin Plaizier, aka Quick Flash, the maintainer of the project EmuFlight. You know, the EmuFlight, the ones that are for tiny whoops and are going in a slightly different road than the BetaFlight. In this time, let's talk with Kevin about why Emu is slightly different, where Kevin is finding his, I don't want to say inspiration, but maybe something like that, to develop new features for the EmuFlight. What are some of the most interesting features in the EmuFlight right now, and when and if we will see the EmuFlight 1.0 release. So let me roll the tape and enjoy the show. So, everything fine? Everything's ready on your side?
Yeah, it should be.
Okay, so I'm recording. Yes, I'm recording. So 1, 2, 3, and here we go. Hello, Kevin. Nice to see you around.
Hey, it's good to be here. Thanks for letting me on.
Yeah, so today let's talk about the EmuFlight and why EmuFlight is trying to be slightly different. Because if you don't know yet, the EmuFlight always try to be slightly different than everybody else in this hobby, in every single other flight controller softwares. And thanks to this, EmuFlight really, to be honest, has a lot of my appreciation. Why? Because not only I usually vote for the underdogs, but also I'm looking with much interest on what EmuFlight is doing. And Kevin over here is the maintainer of the project and the author of quite a few interesting functionalities. I cannot say that I'm a huge fan of all those special features in the EmuFlight, because in some of the cases I'm not. However, this proves that there is always at least a second, maybe even a third way. So, Kevin, why Emu is slightly different? What's your motivation for looking your own way into the flight controller?
Well, yeah, I mean, one large reason why EmuFlight, is going to be different than other projects is there are different people maintaining it, different people writing code for it. So, not everybody is going to think of, what they say, there's like 100 ways to solve a different problem.
Exactly.
So there's going to be different people coming up with different approaches. There's KISS, Flight 1, iNav, BetaFlight, all these different projects. They all do things slightly differently, and some of that's just down to the developers doing things different. And I think for me, what's kind of driven me to, write some code is I've really, I learned how to program writing EmuFlight. I learned how
That's impressive. I really do have to say, that's impressive. Starting with something that huge as the flight controller software to learn development as a developer with like 20 years of experience, kudos for you, mate. Really kudos.
Yeah, I mean, I don't know. It's like when you started programming, it's a different time. Like I learned by looking at commits, by looking at code changes other people had done. So like a lot of my coding style comes from what I've seen other people do in BetaFlight code commits. Because EmuFlight's largely BetaFlight.
That's true.
But
yes. Well,
yeah,
we
and so
all originated from the same base flight.
Yeah, base flight, multi-we.
Yes,
we've got a shared history. It's really neat. But yeah, I learned how to program that way. So my programming style is probably a bit different than a lot of people. And then just, I've learned control theory just through practical application and reading and watching as many videos on it as I can.
Probably the best way to learn stuff. May I ask, what's your major? I think you are in the college right now, yes?
Yeah. So I'm currently at university. You can see on my shirt. Yeah,
Utah.
That comes through. Utah State University. So, yeah, I'm currently studying. They just recently added a drone major to
Nice.
Utah State. So I'm doing that. And then as well, I'm getting a minor in electrical engineering. So good stuff.
Yeah, that's definitely good stuff and a good start for the professional career. So, okay, we more or less know the motivation that you have. So I think it's time for us to have a short talk about 3 features of the EmuFlight. I picked after looking at what you guys are offering in the last few months, and from many, because really the list is quite a longish. But however, I picked 3 features I would really like us to talk. First of all, it will be rate dynamics. By the way, yesterday, when I'm recording this video with Kevin, I yesterday released the video what rate dynamic is, but today we will share like something, a different approach. Then we will talk about the alpha, beta, gamma filtering. Something that I'm personally no longer a huge fan, by the way, Kevin. After today's test, maybe it's not really the best way. However, I know from you and from other people that you have some quite nice experience with alpha, beta, gamma, and finally the Smith Predictor. So let's begin with the rate dynamics. Now the stage is yours.
Yeah. So rate dynamics, if you haven't heard of it or don't know a ton of what it is, it's really a modifier to your rates. So rates, rates are pretty simple. It's just a curve. You move your stick, and there's this curve of what your set point is, and your set points.
Correct.
How quickly
rates translate the stick position to the desired rotation speed on the axis of the flight controller.
Yeah, and so rate dynamics it doesn't modify your rates. You still have the same rates, but it modifies how you reach your rates. It puts your rate curve is really a curve, whereas your rate dynamics is kind of like a curve in time. So if you move your stick halfway, you'll still reach your rates halfway. It just takes some time.
So yes, it's not how the stick position translates to the desired rotation speed, but how in time the flight controller will go into this value. Because there is a difference, that maybe not difference, it's a wrong word. It's almost like a PID controller.
It's essentially a PID controller, and I got some of that idea actually, because when you filter your RC command, you want to smooth out the steps from your RC command, right? So that's pretty steppy with each input, and so when you add filtering to that, you're putting a bit of a curve on your RC because it's not instant.
For our viewers, the filtering has a price. The signal does not go directly to the value it's supposed to go. There is a delay of the signal when you are doing, especially the heavy filtering.
Yeah, and that delay is different depending on the frequency that comes through, and so it's not perfectly linear. But anyways, I was talking to one of my professors at school, and he mentioned that PID is essentially a filter. You feed it some data, and it does some math to it. It gives you some other data out, which is essentially what a filter does.
That's interesting approach. Yes, I never thought about the PID controller as a filter, but think about it, that's correct.
Yeah, so I was like, oh, that's interesting. And I was like, at the time I was actually talking to Bob Rugi, or Kebab FPV, and he really wanted some code that could just smooth out your stick inputs, like kind of force it to look like you're flying with Hypersmooth or any of those other smoothing programs.
Mm-hmm.
And I was thinking about how to approach that, because I was like, okay, that's a decent idea. Just, when you do a sharp flip, it just smooths out the end of the flip, It makes it nice and, a little bit less crisp, but more smooth.
Mm-hmm.
And I didn't want to mess with the PIDs. I didn't want to change how your drone flew to accomplish this. And so I decided to mess around with your rates, because then your drone flies the same, right?
Well, not really the same. I tried rate dynamics, and to be honest, my feeling on this topic is slightly, well, let's say, I'm not really sure what to think about this.
Yeah, I mean,
It's
Yeah.
special, especially when you enable one of those smooth presets, like cinematic or the super cinematic by Kabab FPV. So that's, if you do not have a lot of practice, it's like almost unflyable. I
Yeah,
flipped
it
immediately after
does.
takeoff.
It feels different in the air, like 100%. It feels
Completely
different, but
different.
your quad responds to outside disturbances. Your quad follows set point just as well, right? So your quad still responds the same. It's just that your set point is not responding the same,
Yes,
right?
so we
So
are
in that sense, we're
modifying.
not.
Yes, we are modifying set
Yeah.
point of, like you talked in the beginning, of how your stick translates to the set point that is then later feed into the flight controller. Question: which preset do you use when you fly? Just from curiosity.
I I don't actually use a preset. Usually, I'll come in and I like a I don't use a preset, but I like a little bit more weight, or truly D term. I like a little bit more weight at the center. And then at the end of the stick, I like it to kick just a little bit, with my sensitivity above 100
Mm-hmm.
for the end of my stick. And that way, because rate dynamics, it's really a PID for the center of your stick and for the end of your stick.
Yes, you set up
Um,
completely different weights where for two sticks position. That's
yeah,
for the
and
viewers. Important note.
yeah, yeah. And so, like, I well, another point, I called these PIDs originally, but that just confused users because they're like, oh, how do I tune these PIDs so my quad flies better? And it's like, it's a feel thing. It's not it's not going to get rid of prop wash or anything else. It's a feel thing. But anyhow, I like a little bit more weight in the center and a bit more kick at the end, so I can do a sharp flip. And when I come back, it just smooths the end of that flip a little bit. Just just takes a little bit of the sharpness off of some of my moves.
If you set too much, definitely takes away the sharpness. Okay,
Yeah,
rate dynamics. Like I mentioned in my original video, it depends on you if you will like rate dynamics and
yeah,
the
yeah,
setting of
definitely.
the rate dynamics, because when we spoke previously, you even mentioned that not everybody likes the feeling. I'm
Yep.
personally not that much of the fan of the rate dynamics. However, like, I do understand that for some people this might be almost the next best thing since the sliced bread. But okay,
Yeah, some people absolutely love it. Bob Rugi Kebab FPV, he loves it. He doesn't mind how it changes the stick feel. He just flies with it. And I've heard of some people actually taking this code, forking it into BetaFlight so they could get it in BetaFlight. And so some people just love it. Other people are like, "Oh, I don't like how it changes my stick feel." And that's totally fine.
absolutely,
It's a feel thing as well as, like, if you really want to get smooth video, it can help. And it's also a feel thing. So
absolutely.
if you don't like it, that's fine. Like, if you don't like my rates, that's fine. Fly your own rates. Like, it's optional.
Definitely. Okay, enough about the rate dynamics. Let's go to the alpha, beta, gamma. And once again, I will I will be honest over here. I don't understand the math behind the alpha, beta, gamma. I never spent enough of the time to understand it. So maybe you could quickly explain what the alpha, beta, gamma filter is and why it might help you remove some of the noise from the gyro and the D-term in the EmuFlight.
Yeah. So the alpha, beta, gamma filter, it's really quite similar to a Kalman filter. It just isn't quite as dynamic. It's more of like a static-ish version of a Kalman filter. So they're kind of closely related.
That does
But
not compute the covariance, right?
yeah, it doesn't do any covariance type of Kalman calculations that Kalman filters do. It's essentially that without that part. And for our use case, the performance is going to be like 95% the same as a true Kalman filter. So it's probably not worth our time to do the full Kalman covariance stuff with this.
But we are already
But
doing that, by the way, both Emu and the INAV.
yeah, in a different sort of way. So this is like a much different sort of Kalman filter, because with Kalman filtering and other stuff, there's more than one way to do it. So with the alpha, beta, gamma filter, though, you use kinematics. And if you don't know what kinematics is, it's a term used in physics, and kinematics relates to motion. So it's really a kinematic type filter. It looks at the drone's, well, it looks at the velocity of the gyro, but we'll just pretend the velocity is a position because this makes it easier to visualize.
I'm not sure if this. I'm not sure it really helps to visualize. But okay, maybe let's phrase it in a different way. It computes a series of derivatives. I think
Yeah.
maybe.
So like if you've taken like a physics class or you know enough about calculus and physics, you have your position, and if you know what your velocity is, you can say how your position's going to change,
Yes.
right? Because if I'm driving 60 miles an hour, 1 hour later,
You will be
my
60
position
miles
has changed 60 miles,
further
right?
away
So
down the road.
this filter looks at your position, your velocity, your acceleration, and your jerk, which jerk is the change in acceleration. It looks at all
Yes.
of those things and says because of how the gyro is moving, we can predict that this will be the next movement.
Yes, because if we know, for example, the jerk, we can guess, compute the acceleration. If we know the acceleration, we can know the velocity, and then we can know the position.
Yeah, that's the general idea. Is we can know we can get a fairly rough estimate of the velocity, acceleration, and jerk, and that can give us a estimation of what the new position is. And so it does that math, and then based on the gyro input versus what it predicts, it corrects its prediction and
So
says,
it's a
"Oh,
predictive filter.
yeah, yeah, it's predictive." And it's fairly neat in that sense because it makes sense that normal physics, you know, position, velocity, acceleration, that sort of stuff would carry over to drone stuff. And
Because
we
drones fly thanks to physics.
yeah, so it's a fairly decent estimate at what's going on, which is pretty neat, and it makes a lot of sense, I think, from that perspective. And so because it's a movement filter, it's kinematics, it needs movement. It only works on your gyro and your D term. If you tried to stick it, to filter your battery voltage, like it wouldn't work. Like there's no
No,
there's no
because
velocity to
no.
voltage. So
Well, there is a velocity, but it's really like kind of slightly different
yeah,
approach to the problem.
it's a much different thing, right? So it only works for your gyro and D term because D term is based on the acceleration, right? It's based on
Mm-hmm.
movement still. So we can still stick it there because it's movement. And your gyro is movement, so we can stick it there and it can predict it.
Does it mean that we can drop all the static low pass filters and just put alpha, beta, gamma over there and go flying? And this is a tricky question, I know.
Yeah, that's not the case. I thought it might be when I was first messing around with it, because I read about the kind of filter online and implemented some stuff, but just testing, if you remove a low pass, the prediction kind of breaks. I think that some of that's just like if there's too much noise, then you can't accurately predict if there's too much noise, right?
Definitely.
Because
Definitely.
you just ruin the prediction. So you need to have some. It needs to be fed filtered data. If it's just fed like frame resonance, it'll try to think that frame resonance is real
Is a
movement,
movement, and
and
that will like amplify the movement, which is not really a movement, and will lead to problems, which by the way I encountered today during my testings.
yeah,
I
and I
did
mean,
encounter that it cannot really replace the LPFs. However,
yeah,
based on my experiments, it has a very wide attenuation of noise.
yep.
It's not like you
So
set it to the frequency, it just attenuates almost everything.
yeah, it's pretty nice. It kind of grabs everything, and because it's predictive, if you feed it filtered enough data, like if you feed it too raw of data, you're gonna have a bad time. But if you feed it good enough data, it's a very, very low latency filter because of that prediction, and it just kind of, like you said, kind of takes out a lot of broadband noise, and like the high frequency noise, like really high frequency, it just like completely squashes that. So kind of has like a steeper cutoff than a normal low pass filter, but it's obviously a bit different. But you know, from my testing, I've found that I can raise my low pass filters higher when I stick the alpha, beta, gamma, and so in total, I'm reducing my latency a bit.
Yes, and low latency is super important. But okay, enough of the filtering. Now let's go into another aspect of the prediction, and this is, to be honest, my favorite. In the last probably year, this is my favorite because it's genius. It's genius, and this is. We will be talking about something that was invented in the 50s of the previous century. Somewhere around 1957, if I remember correctly from the Wikipedia, a guy named Smith designed a predictor, which now we call the Smith Predictor, and EmuFlight 1.0 will have it, right?
Yeah, and EmuFlight 0.4.
0.4 and also iNav 3.0, because I ported this. This is really something I really do love in the air. iNav 3.0 also will have a Smith Predictor. So, stage is yours. What is the Smith Predictor?
Yeah, so Smith Predictor, like you said, it was invented in the 50s by some guy named Smith. I don't remember the rest of his name, but it's a pretty novel idea. And the idea is really, you know, if there's delay in a system that you're trying to control.
A known delay. This is important. This has to be a known delay.
Yeah, if it's an unknown delay, you can't predict for it. So it's a known delay. So say you have some system you're trying to control. Maybe it's a heater or anything, and when you go to flip a switch, it takes like a second for the switch to actually do anything. That's a known delay of 1 second, and because of that, we can do some prediction on it and say, oh, we know there's delay, so we can control better because we know what that delay is. And in terms of our drones, we put filters on our gyro data.
A lot of filters.
We also
a lot.
Yeah, we put a lot of filters. You know, we have the built-in, like they call it the digital low pass filter or the anti-aliasing filter, and that's what the gyro. That's a filter we can't remove. That's just on the gyro.
Yes, exactly. And even the specification, for example, for the MPU 6000 says that internally the MPU has 0.98 milliseconds. And you cannot lower
so almost
this
a full millisecond.
You cannot lower this.
Almost a full millisecond of delay that you can't get rid of. And then we have, you know, we got the notch filter, you know, the dynamic notch. We've got the low pass filters, alpha, beta, gamma, if you're using that. We got all sorts of different filters down the line, and it takes your gyro data, and you get some raw noise. It's going to be really spiky, right? Because we got lots of noise going on, some raw noise, but we have to shift it in time in order to smooth it when we filter. So we end up with a few milliseconds of delay, like 5, maybe even more, depending on how you set up your filters. You end up with delay. And as we know, the more delay you have, the more prop wash you'll have because your drone is acting on old data. And the idea with the Smith Predictor is we get a pretty rough, doesn't need to be a perfect estimate, but just a pretty, you know, it doesn't need to be anything perfect, just get it closer. We get a good estimate of the delay in our gyro, and we then use old gyro data to predict kind of forward what our gyro data was, say 4 milliseconds back in time.
Because this one I understand about. The idea is that the delay equals the delay between current sample and the sample that happened like 4 milliseconds. If you take the difference and you add it to the current value, you have a compensated for the known delay sample. At least something like that.
Yeah, and it's not perfect, you know. Obviously, it's not gonna be a perfect picture. You know, it's not taking. It doesn't take our filtered gyro data and shift it perfectly over, because I mean, for this prediction, we're really just looking at a shifted in time, whereas with the filters we do, it shifts different frequencies differently in time, and our prediction doesn't account for that, but it gives us a better picture, a closer picture. That's actually
correct.
happened.
That's correct. Let me break you for a second. My feeling is that when you just fly like the cinematic regular stuff with Smith Predictor, you do not really feel any difference. It flies exactly the same. However, when you go into those fast maneuvers, when you are changing the direction very often and very fast, use a lot of throttle, the whole quad feels more like on tracks. It's like it's better in those very specific moments.
Yeah, and you know, prop wash performance, it can help a bit.
This
And
is
just
important.
yeah, it's pretty nifty. And like I mean, I found out about the Smith Predictor by reading some D Ronin code. And if you don't know what D Ronin is, it's a now defunct flight software, you know, kind of made by the same guys that brought us the CC3D.
Yeah, it's exactly the same.
And
It's an open pilot, then
yeah,
it was Libre pilot, then it was Ronin, I think.
I think it was like Tau Labs and then
Tau Labs
D
in the
Ronin.
middle, yes, and in general, they are dead for like 2 years at least.
Yeah, it's been a while, but like I say, I learned how to code by writing EmuFlight code. So just reading other projects, seeing what other projects are doing, that's fun for me. Just seeing like, oh, this other drone project did this. Let's see if it's actually useful. Let's give it a try, you know. So they had a pull request opened that it's probably never going to be merged because their project's pretty much dead at this point. But they had a pull request for a Smith Predictor on the motors. Because I mean, the motors have a little bit of delay as well, but they were sticking the Smith Predictor on the motors. And I actually reached out to the developer that wrote that and spoke to him a bit. And he suggested that I stick it on the gyro and give it a try. And you know, the math would be a bit simpler there. And I was like, okay, I can do that. Let's give it a whirl, see how it does. And you know, so it's not my idea. You know, I was able to port the code over. I was able to change it and get it to work. And I understand the theory behind it, but like, I'm not just going to take credit for this.
Yes, the credit goes to the guy called Smith.
Yeah, he's the guy that originally did it, and it's, you know, it's working now, and I'm quite impressed that, you know, just it's really simple code if you've been programming a ton. It's quite simple. It just, you know, we just look at our old gyro data and use that to predict what our current reading should be compensated with, and boom, your drone's flying better.
Yes, that's definitely the case. Okay, so
Yeah.
those were the 3 features I really wanted to talk to you about. And now let me ask you a very important question. When we gonna see this mythical EmuFlight 1.0? What's the roadmap over there?
So there's currently no ETA or release date, and currently we're even pushing EmuFlight 0.4. So like most of what we've spoken about today, actually all of that stuff will be in version 0.4. And the EmuFlight 0. whatever number, that's based on BetaFlight that EmuFlight started out on, which is pretty much just BetaFlight 3.5. EmuFlight 1.0 is BetaFlight 4.3, and really EmuFlight, we're keeping up to date with the latest BetaFlight stuff and just sticking all of our Emu stuff and making different changes to things. And like I've checked the number of commits I've done on 1.0, it's like a couple hundred. So there's quite a few changes. It's not going to be BetaFlight 4.3. But the biggest thing holding us back is we're completely redoing the GUI. We're doing something completely new, and it'll make it nicer for us developers to work with the GUI once it's done.
Oh yeah, this problem.
And
let me cut in for a second. I spent a lot of time developing the iNav configurator, which is just was forked from the CleanFlight, and I know how this thing looks like in the guts. Oh boy, I hate it. Oh no, really. If
yeah, it's bad.
it's bad, and because the EmuFlight configurator is based basically on exactly the same source, I know why you are trying to rebuild the graphical user interface, and I can only vouch for you that you will do it. Like, do it.
Yeah, like we've got some cool stuff in the works. Like some of the GUI problems that you run into is this multi-WE serial protocol stuff, and everything has to be aligned. If you want to add any new setting to the GUI, you have to change your multi-WE serial protocol on both ends.
Look at the iNav 2.0 settings framework. But you don't have to change it. You will be surprised.
That's
Look at it. It's amazing.
okay. We've come up with something else that gets around the problem. I'll need to take a look at what you've done, but we've got, you know, a different way where we just have the drone send us a JSON that tells us how it's completely configured. But currently, that's our biggest.
That's interesting.
Like,
that's very
pain
similar
point.
to, I think, to what OpenPilot was doing. I think they always were sent. I think they always also were sending JSONs. Maybe I'm wrong. Never mind.
I don't know. I haven't been through the the OpenPilot stuff enough, but we're rewriting the GUI, and that's it's taking a fair bit of effort. Like currently, when I fly 1.0, I still have to use the BetaFlight configurator, and a lot of that configurator is just completely broken. So I use it very minimally, and I'm pretty much just in the CLI doing everything, or in the OSD menus on my goggles setting up. Like it's once we get the GUI working, the code's pretty much ready to go as far as flight stuff goes. But since we're still waiting on the GUI, you know, there are new flight improvements that keep showing up because I just get too excited with trying out new different things that can happen and make your drone fly better. And so I just shove it in there. We're still waiting for the GUI, so it's like this
feeling.
doesn't.
I know the feeling, mate.
Yeah. So we're waiting on the GUI. The biggest help we could have now is just some guys that know JavaScript decently come and help.
No, I will not help you. No.
Which I'm not a JavaScript expert, so for me it's like I haven't done a whole lot with the GUI. It's kind of, you know, painful just dealing with that sort of stuff. So I'm just on the C side, which a lot of people seem to not like as much as JavaScript. So I guess that's where we're at.
There are good things in both of the worlds.
Yeah, so that's just kind of where we're at. We're waiting on the GUI, but 0.4 it'll have a lot of the flight code changes, but it won't have all the good stuff from BetaFlight. You know, like the unified targets, like all the other improvements. Like we will have the RPM filter. We will have some other stuff that's BetaFlight has added, and more support for things. So it'll be a good improvement. But most of the flight stuff that I've changed, I've just backported it to 0.4 so that other people can appreciate it while we still push to get this new GUI created and made. So it's a process, but you know, things are coming along. I wish I could give ETAs.
It's the hardest part of giving the ETA, because then somebody will try to make you accountable for your ETAs.
Yeah, it's especially when, you know, this is open source. We're doing this work. We're not getting paid for it. Like we can't, you know, it's not like a business where it's like, oh, we have a date. You know, you have to be done by the 5th of June, or
if it won't
or
be
else,
done,
you know, you have this hard date. Like, what are we gonna fire the guys that are giving us free work if they don't do things quick enough? Like, no, you got to treat those guys right. You know, we want to keep anyone that's helping us. So no real ETA, unfortunately. But you know, as we get further along, we'll be pushing for more people to help test stuff for us. But I mean, currently you have to do pretty much everything in the CLI, which I know scares a lot of people. So
I was afraid, by the way, I started as the OpenPilot pilot. And then the people were talking, oh, use this CleanFlight, it has this CLI, it's so amazing. I was like, no, I don't want to use the CLI, I don't want to type in commands. But then at one point I tried, and okay, commands, they are not really that bad. So maybe it's worth the effort to get used to the CLI at one point.
Yeah, it's definitely worth your time, but I mean, it still scares a few people. So even if it's not the toughest thing ever, it's still just convincing people of that, you know.
Okay, Ken.
Like, you know, I know that some, but
okay, no, please finish. Anyways. Please finish your thought.
No, I was just saying, you know, just some things scare people. Like I've heard some people that have heard of the Smith Predictor, and they're like, oh, it has the word predictor in it. I don't trust stuff like that. Like, oh, predictor, like, I'm really skeptical. So I know that regardless of what you're doing, even if it works or not, there's going to be skeptics. It takes time.
And
So
you
it's
have to have open mind. And please, skeptics, please have open mind.
yeah. I mean, with anything, it takes time, and like the market has to adapt and evolve and accept different things. It just takes time.
Definitely. Okay, Kevin. Thank you very much for joining me in this for you Saturday morning. For me, it's the Saturday afternoon, and that was very nice. How long have we spoken? 40 minutes? No, 30. Almost 40 minutes. So I think that maybe the video will be slightly longer than originally predicted, but still, I think it was a very valuable conversation. So thank you very much for joining me and sharing some of the secrets and the wonderful world of the EmuFlight with my viewers. And I wish you all the best with your pursuit for the perfect, not the perfect, the flight controller, and good luck with the moving day for you, mate, today.
Yeah, and thanks for porting over some of this code to iNav. It's cool to see it used in other projects.
Not everything. I'm porting, but I'm not merging everything. Do remember, not everything, because it's not that everything that you guys made I find like okay worth it. But some people are really amazing. Some like okay meh. Like for example the ray dynamics. Anyhow,
Yeah.
so I think we will be ending over here. Thank you very much to you, Kevin, for joining me, and to all my viewers for sticking up until this very moment, and until the next one. Bye bye.